Welcome to RSCH503, Research Methods and Biostatistics, a 3-credit graduate course offered by Drexel University College of Nursing and Health Professions. Through measurement, researchers assign numbers to objects, events, or situations according to some rule. Thus, by number assignment, statistical analyses can be applied in quantitative studies. Rules of measurement are applied in the design of an instrument used to measure a variable of interest in research. Well-designed quality instruments obtain reliable and trustworthy data when measuring variables. Think of the phenomenon of blood pressure, defined as the pressure exerted by circulating blood upon the walls of blood vessels, usually referring to arterial pressure in the systemic circulation. The sphygmomanometer is an instrument, when functioning properly, which directly measures BP. The sphygmomanometer is an example of a direct measurement. Another includes a scale to measure body weight. Researchers also use indirect measurements to measure concepts, abstract ideas such as pain, coping, and others. Once defined conceptually, such abstract concepts are then measured indirectly through the use of well-designed self-report scales or questionnaires. No direct or indirect measurement used to measure a phenomenon does so perfectly. Measurement error is the difference between what exists in reality and what is measured by an instrument. It is important to appreciate that error is inherent in any measurement strategy. When an instrument measures a variable, there are 3 components to the obtained score. First, there is the true score, that which would be obtained if there was no error in measurement. Second, there is the observed score, that is, the score obtained by a subject on the instrument used. And third, the error score, that is, the amount of random error in the measurement process. The smaller the error score, the more closely the observed score reflects the true score. In exploring the notion of an error score more fully, we can see that it has 2 parts. First, a random error component, or capital E subscript R. Random error causes individuals' observed scores to vary in no particular direction around the true score. And second, a systematic error component, or capital E subscript S. Measurement error that is not random. Measurement error occurs because something else is being measured in addition to the variable of interest. Thus, X, or subject's observed score, is equal to true score plus random error score plus systematic error score. Decreasing systematic error, or capital E subscript S, must be addressed prior to conducting a study. Most critically, instruments used to directly or indirectly measure variables must be reliable and valid. They must very closely conform to the underlying conceptual definition. Occasionally, researchers will employ a multi-method, multi-trait technique to ensure quality data. This technique requires the use of more than one reliable and valid instrument to measure a variable. The rules of measurement employ a hierarchy in terms of level of measurement, from lower to higher. There are 4 such levels. First, nominal data. This is the lowest of the levels. Nominal data can be organized into categories of a defined property, but the categories cannot be ordered. The categories are unorderable, exclusive, and exhaustive. Gender is a good example. Second, ordinal data. This is the second level. Data measured at the ordinal level can be assigned to categories of an attribute that can be ranked. The categories can be ranked, are exhaustive and exclusive. Pain and coping ability are examples. Third, interval data. This is the third level. The distances between intervals of a scale are numerically equal. Interval categories are mutually exclusive, exhaustive, with rank ordering. Interval data are assumed to be on a continuum of values. An example includes temperature. There is no 0 point on an interval scale. Lastly, there is the ratio scale. This is the highest form of measure and meets all rules of measurement: mutually exclusive categories, exhaustive categories, rank ordering, equal spacing between intervals, with a continuum of values and having an absolute 0 point. An example would include laboratory diagnostic values. Both interval and ratio data are continuous. Investigators strive to use the highest level of measurement possible in their research studies. Mathematical operations are limited in the lower levels of measurement. Non-parametric statistical analyses are employed with nominal and ordinal data. Parametric statistics can be used for interval and ratio data. With parametric statistics, the distribution of data is expected to be normal or approximately normal. Thus, stronger inferential statistics can be used to explore relationships among variables or to determine differences between groups on a specific variable. Parametric statistics enable inferences to be made from the sample data to the target population of interest. Two key concepts in instrumentation include validity and reliability. Validity of an instrument means, essentially, does the instrument measure what it purports to measure? If the instrument is thought to measure what it purports to measure, how well does it do so? Instrument validity procedures deal with the relationships between performance on an instrument or test and other independently observable facts about the behavior characteristics under review. There are 6 types of validity to consider when examining an instrument's validity. Each of these types of validity is examined separately. 1. Face validity, or readability of an instrument. 2. Content validity. 3. Construct validity. 4. Criterion-related validity. 5. Convergent and divergent validity. And 6. Evidence of validity via discriminant analysis. First, content validity. Is the content of the instrument or test used in a study truly representative of the behavior domain to be measured? For example, does an instrument used to measure anxiety truly measure anxiety? While it is essential for an instrument to have content validity, there are several difficulties to ensuring it. For example, the instrument must sample the universe of possible items, often termed sampling the item universe. Overgeneralizing or undergeneralizing the item universe can be problematic, along with inclusion of irrelevant factors in the instrument. There are several methods used to obtain strong content validity. Researchers develop content samples of the phenomenon to be measured and then choose items from that sample. Content maps or test or instrument specifications may also be developed of the phenomenon, with samples of items chosen from them. Obtaining ratings on items from content experts is a valuable way of determining validity, with ratings of experts independently compared for inter-rater reliability. Additionally, correlations between individual item scores to total scores will provide data to researchers. Content validation is used in many situations in which valid instruments or tests are employed. In education, for example, teachers develop content maps of their course content from which to develop test items. Achievement tests also employ content validation procedures. In occupational tests, job analysis, a form of content validation, is used to determine knowledge and/or skills. Content validation is not as relevant in personality or aptitude tests. Other procedures are used in these tests. Criterion-related validity procedures indicate the effectiveness of an instrument or test in predicting a person's performance in specific situations. In this case, performance on an instrument or test is checked against a criterion, that is, a direct and independent measure of that which the test is designed to predict. Thus, criterion-related validity includes both predictive criterion-related validity and concurrent criterion-related validity. In predictive criterion-related validity, prediction is made from the instrument or test score to any other criterion situation or to prediction over time. For example, do GRE scores predict success in graduate schools? Does the GPA predict success on the NCLEX RN exams? Do ANCC or AANP board examinations predict success or quality outcomes in advanced practice nursing? This presentation was prepared for graduate nursing students at Drexel University College of Nursing and Health Professions. The primary book used in this research course is The Practice of Nursing Research, Appraisal, Synthesis, and Generation of Evidence, 2017 edition by Jennifer R. Gray, Susan K. Grove, and Suzanne Sutherland. This book is published by Elsevier Saunders, St. Louis, Missouri.